Good morning, ladies and gentlemen, and welcome to the BioData World Congress Day 2. I'm honored to invite our next speaker to the stage, Angela Bauch, who is the Assistant Director of Product Management at Biomax Informatics AG. Angela will today be speaking on insights from AILANI, an AI-augmented question and answering and semantic search system for life science enterprises. Angela, the stage is now yours.
Thank you, Edward, for the nice introduction. AILANI stands for Artificial Intelligence Language Interface. AILANI is a semantic search platform that combines and connects multiple data sources. Its technology is based on linguistics, natural language, and artificial intelligence. You can ask AILANI all kinds of questions, such as how to treat schizophrenia, or how does SARS compare to the Middle East Respiratory Syndrome virus, or what is a BCR-ABL inhibitor, or how to prevent cytokine storms in COVID-19 infections. And you're presented with relevant answers. AILANI consists of a user interface which is easy to use and intuitive. It has a simple search box where you can enter your keywords, phrases, or natural language questions. And here you're redirected then to the results page. This is the document-centric view with the keyword results, but you're also presented with AI answers in another tab. Within the document-centric view, you can further drill down and refine your answers based on domain-specific ontologies like the disease ontology or the compound ontology or the organism ontology. Here we have an example of the disease ontology represented by this colorful sunburst diagram, where you can really drill down and navigate further to more specific concept types. You can further track your search by using these colorful breadcrumbs at the top of the page, which are automatically saved as your search history. You can also create your favorites of your searches, or you can subscribe to an alert and to be updated on new content and new results based on always new content which is being ingested into AILANI. How does the workflow of AILANI look like? At the center, we have this huge, large knowledge graph, which is continuously growing, and we maintain this. And input can be structured data like Medline abstracts, or it can be also free text, unstructured data. It can be your in-house document, like, for example, your Word documents, your PowerPoint files, or electronic lab notebooks. And also we have really up-to-date news. The news archives are also being processed. And all this data is subjected to specialized data detectors and pattern detectors. We also extract chemical information by applying OCR and OSR, which stand for optical character and optical structure recognition. We crop structures from a page, which are then translated into a SMILES and then are available for a search. And here from this knowledge graph, this is subjected to tagging and indexing, and we provide different search algorithms for the global search. One is based on machine learning system, and the second one is an NLP query parser. In addition, we provide also a sophisticated concept search with this manual drill down possibility using this sunburst control, which I've showed you earlier. And the chemical perspective is also that we provide a chemical search, which I will show you later in this presentation. With the start of the pandemic early this year, Biomax decided to make a COVID-19 AILANI publicly available, which you can access here at www.ailani.ai. This installation contains the following content literature. So we have the full set of Medline abstracts. We have about 2 million full text articles from PubMed Central, the full set of clinicaltrials.gov. We have the COVID-19 specific literature, which was made publicly available from publishers like Elsevier, for example. We also have the preprint papers for medical and bioarchive, and we have the relevant COVID-19 news feeds also integrated. And most recently, we have also integrated coronavirus-related patents in a collaboration with Sagacious IP this summer. And if you're interested also to compare your own documents, it's always possible within an AILANI installation to extend it with your proprietary documents, your Word files, your PowerPoint files, your electronic lab note books. We have also integrated about 70 public databases ranging from UniProt, KB, Campbell, DrugBank, PDB, and so forth. And these are also extendable by your proprietary databases. It can be your antibody inventory, your chemical library, or your IP portfolio. And at the heart of AILANI, we are the ontologies, which are very critical, which we are maintaining and always expanding. So we have about 120 life science ontologies, like the disease ontology, gene ontology, NCBI taxonomy, KB, just to name a few. And also these are extendable by proprietary ontologies or to extend existing ones, for instance, to include also your product names. How does the AILANI knowledge graph look like? It's a large network which consists of ontology relations, which are hierarchically built. Let's say this is the protein ontology. Here we would have the protein kinase, and the protein kinase would here have a child concept, which is the non-receptor tyrosine kinase, and here the receptor tyrosine kinase, which in turn has individuals like the EGF receptor or the PDGF receptor, and non-receptor tyrosine kinases would have individuals like SARC, LIN, FIN, ABL, and so forth. These individuals in turn are linked then to their gene products and have cross-references also to other databases. So that's what the big knowledge graph consists of. And an AILANI starter knowledge base has approximately 44 million triples. And the customer implementation typically has 10 times more. And the question answering index now is a combination of these semantic networks and neural networks, which here we refer to the AILANI hybrid AI, which combines prior knowledge contained, for instance, in the high quality relations derived from ontology relations, and then combined with reasoning and generalization and neural networks, still finds yet unknown concepts within this large semantic network. And here, how does now this sophisticated concept search work? As an example here, we are searching for lung cancer within the set of clinical trials documents. And here on the right, we have an excerpt of the disease ontology with lung cancer as a parent concept, lung carcinoma, a child concept, and non-small cell lung carcinoma, again, as a child concept. And as you see here, we not only retrieve the parent concept lung cancer, but also a child concept like pleuropulmonary blastoma, as well as non-small cell lung cancer. So it's not only a keyword search, it's a concept search. So we infer for the child concepts, and we also extrapolate for all the synonyms which are associated with these concepts. What are the two algorithms? The first algorithm is the NLP question answering. Here we have depicted the network, which consists of these triples. For instance, here the triple consists of a subject, surname, and here the object, osteosarcoma, and the linking predicate effects, surname affects osteosarcoma. And the NLP parser in the first step analyzes the grammatical structure of the question, and then the entered question is translated into query against all previously exacted triples, and then the object of interest is then reported, including the original source where it was extracted from. The second algorithm is the AI question answering. Here, we typically extract a candidate set of 4 sentences chunks, which most likely contain the possible answer. And these candidate sets is generated using the semantic tagging index, using also ontologies for contextualization. And here, therefore, the quality actually of these ontologies play a critical role also in the quality of the answers which are retrieved at the end. And from this candidate set of 4 sentence chunks, a neural network extracts direct answers to the entered question. And then based on a machine learning score, the answers are then reported in a ranked order. So now let's ask a question, AILANI, like how to mitigate COVID-19 associated cytokine storm. Here within the direct answer, we are reported here with the first result, ruxolitinib, which is an inhibitor for JAK, which has an effect on cytokine receptor signaling. On the right, we have the info box with some more additional information on this inhibitor. We have the structure information, we have the INCHI key and cross-references to other databases. And selecting here, view knowledge graph, we are redirected here to the graphical network representation, having ruxolitinib as a central node connected to other concepts like anti-neoplastic agents or mononuclear cell proliferation. The size of these nodes actually represents the connectivity within the network. The bigger the nodes, the higher the connectivity. And by selecting any node or edge between these nodes, we have additional information here in this on the right on the info box. Selecting one of these nodes, for instance, we can retrieve all the evidence behind the association. Here, for instance, ruxolitinib inhibits mononuclear cell proliferation. Here we have the highlighting of this triple within the text, and we have reference to the respective literature source. We can also extend and expand this graph because typically we limit this path size of these networks to a certain size that we avoid making these hairballs in order to have better overview. And here, if you're interested to explore further from mononuclear cell proliferation, you select that, expand it, and can explore further. So this is the original network based on ruxolitinib, and here we've selected mononuclear cell proliferation and can expand this network. Now, what's the chemical perspective of AILANI? We have integrated a ChemDraw tool where you either can draw your structure of interest or you upload your file as SDF, MOL, or CDXML file. And you're here redirected then to the results page where we perform similarity and substructure searches. And here, this is a similarity search where results are ranked by similarity score. And we also have here a link to the documents where ruxolitinib was extracted by optical structure recognition. And in this example, this structure was extracted from a US patent. Here we have all the metadata for this patent. On the right, we have the full PDF. In addition, we also have information about all the other structures which have been extracted from this patent in addition to ruxolitinib, with the exact page number where it was extracted from. If your answer is a gene or a protein, we also have specific gene report with genomic information. We have the genome, the chromosome location. We have cross-references here to ontogene, ensemble. We have protein function information. Additionally, we also have protein-protein interaction. Here an example of the MERS receptor dipeptidyl peptidase 4. We have all the protein-protein interactions from BioGrid integrated, as well as gene disease association from DisGenNet. And recently, we have also introduced the concept of personas, which has different user experience for different user groups within the same installation. So this is the generic version of AILANI. Here we have the COVID-19 version, and here the nutrition version. And we also expose user group specific example questions, which are accessible here within the info icon in the search box. A drop-down menu displays then all the questions which always change. We add always new ones. And these are actually the one are contained also from the White House Channels challenge, which was initiated this year in April. And they all revealed actually high quality answers. In addition, we also have user group specific refiners associated with these personas. For instance, for the nutrition, we have integrated the food ontologies, which is accessible here for refining your results. And for the COVID-19 installation, we have exposed the signaling pathways, which are of interest to understand better the pathobiology of SARS, and as well the coronavirus itself. So this is a sub-branch of the NCBI taxonomy representing the beta coronaviruses. And here I would like to conclude. So with AILANI, I could show you with natural language questions like how to mitigate COVID-19 associated cytoscore. We could find inhibitors, which are currently in clinical trials also for COVID-19. We could explore the answer within the knowledge graph, and we got also chemical information and pattern perspective from a potential drug like ruxolitinib. We got detailed genetic information background with the example of DTP4. And with the personas, I could show you that with one installation, within your organization or your company, you have the option for different user experience for the different research domains of your group. Yeah, and thereby I would like to conclude, and I'm happy to take any questions.
Thank you very much, Angela. Wonderful presentation. We do have a question from the audience. We have a question from Saritha, who's asking, are the different evidences used to generate the knowledge graph ranked?
Yes, we have a ranking method. It's a combination since the answers are actually combined from different algorithms. So we have machine learning answers which have their own ranking. Then we rank high, for instance, answers which are derived from ontology relations, which are highly, high quality curated knowledge. And we have an own ranking system for the triples which we retrieve. So between these three different algorithms and different types of answers, we have a combination of ranking, which is then combined.
I'll just wait to see if there are any further questions from the audience.
Mm-hmm.
Angela, I think that's all the questions we have for today, but thank you very much for being with us and joining us on the BioData World Congress 2020. It's been a pleasure hosting you.
Thank you.